Alaikum, c'est Vivian Shwaikani. I'll be explaining Chapter 11, Carboxylic Acids and Their Derivatives, Part 1. In this part, we have those objectives: to recognize the carboxylic acid, to name them according to IUPAC, to recognize their physical properties, and finally to write the equations of the carboxylic acid with water, strong base, and alcohol. So let's start first of all with our first objectives. We know well from the lesson functional groups carboxylic acids. So let's define it. Carboxylic acids are organic compounds that contain at least one carboxylic group, and you know the carboxylic group. If the organic compound contains only one carboxylic group, it will be called mono-carboxylic acid. If it contains two carboxylic group, it would be called di-carboxylic acid, because di refers to two. And sometimes some organic compounds contain more than two carboxylic groups. They will be called polycarboxylic acid. In this here, we will be limited to mono-carboxylic acid. It means having only one carboxyl group. So the general formula of the mono-carboxylic acid, and sometimes they will be called simply in the coming parts carboxylic acid, their general formula is RCOOH, and you know well that if the chain, the carbonate chain of a saturated saturated non-cyclic monocarboxylic acid, the general formula would be written in terms of N, and it will be CnH2nO2. So this is the first organic compounds that has two oxygen atoms in its general formula. And as we said, in this year, all carboxylic acids we will deal with will be saturated and non-cyclic. So in exercises, you have the right to use this general formula directly instead of RCOOH. The second objective is the nomenclature of monocarboxylic acids, definitely according to IUPAC. So here you have to pay attention to many rules set by IUPAC. You have to make sure of the following. First of all, the main carbonate chain in carboxylic acid is the one including the carboxylic group, as all compounds. And the carbon of the carboxylic group is always given the number 1 as the carbonyl group in aldehydes. So in aldehydes and in carboxylic acid, the carboxylic group is to an extremity of the compound. The name of carboxylic acids consists of two words, where in the first, the suffix, it means the ending of this word, is oic, and the second word is acid. So let's consider an example. The general name will be alkanoic acid, two words. Don't stick a lot to this if it bothers you, but this is the general name that fits all carboxylic acid. What do we mean by alkanoic? Look at this example. Here is the carboxylic group. It is attached to carbon number 2 because this carbon is number 1 and this one will be number 3, and we have here a methyl branch or branch. So the name will be 3-methyl butanoic acid. Why butanoic? Because look, 1, 2, 3, 4 in this chain. So it would be 3 because here is the branch methyl attached to butanoic and acid, and as you can see here there is a space so between these two words. Let's give an application. Give the IUPAC name of the molecules whose condensed structural formulas are the following. First of all, we have to examine the functional group. Look here, it is C double bond O OH. So it is the carboxyl group. So automatically the molecule will be what? Will be a carboxylic acid. And here is the same. So this is carbon 1, 2, 3, 4, and I have a branch on carbon 2. This branch is of methyl type, so the name will be 2-methyl butanoic acid. Here also I have a branch on carbon 2. This branch is chlorine, so it would be chloro. So it would be 2-chloropropanoic acid. Okay. Now about isomerism. Carboxylic acids exhibit only skeletal and functional isomers. Definitely they don't have positional, because the functional group, as we said, is always to the extremity of the chain. Esters and carboxylic acids are considered to be functional isomers since they have the same molecular formula CnH2nO2 but different functional groups. This fact is seen in the first lesson about functional groups, and here it is repeated again. Now, write all the possible skeletal carboxylic acids isomers of C5H10O2. Do a pause for the video and try to write those possible skeletal carboxylic acid isomers. When I say skeletal carboxylic acids, it means I don't need you to write all the isomers. I don't need, for example, ester, which are functional, because everything related to esters will be studied in details in the coming lesson. So after the pause, this is the solution. So these are the possible skeletal carboxylic acids having the following molecular formula. Now let's move to the physical, or before, let's generalize. Here is the family. We have carboxylic acid, we have ester. As you can see, the general formula is here RCOOH, while here it is RCOO R prime. So instead of H here I have R prime, and this is how to memorize the general formula. In terms of N, they will have the same, CnH2nO2. Why? Because they are isomers, as we said. Now, regarding their molar mass, look at the molar mass. You know that each carbon has a mass equal to 12. So here it will be 12N for carbon in terms of N, and hydrogen has a molar mass of 1. So 2N plus 12N, it will give me 14N plus 32. 32, it is 2 of oxygen multiplied by 16, which is the molar mass of oxygen. So esters and carboxylic acid, definitely the corresponding ones, will have the same molar mass since they have the same general formula. The functional group here is carboxylic groups. Pay attention when it is required in an exercise to write the carboxylic group here. Don't forget to write this dash that represents a single covalent bond that is here. This bond is very important to say that this carboxylic group does not exist in the free form in nature, but rather it is combined or it is attached to an alkyl group here. And for ester also, there the functional group is called ester group, and it is COO. Also here, pay attention to represent two single covalent bonds from each side, one from each side, to say that this group, as you can see here, is attached here to one alkyl group and here to another alkyl group. Now the general name, as we said, here is alkanoic acid, here is alkyl alkanoate. Also here, don't stress a lot about this word, but memorize those facts related to ester, because as I repeated, ester will be seen in details in the coming lesson. Let's move now to talk about the physical properties of carboxylic acid. First of all, they are solids or liquids at room temperature. This is not to be memorized, but it's a fact to pay attention to. The liquid carboxylic acids are volatile. What does the volatile mean? It means the liquid carboxylic acid, when they are exposed to air, they will transform into gas, into vapor, it means quickly. This is similar to alcohol, because alcohol, for example, if you put a little alcohol on your hands, automatically or rapidly, what will happen to this alcohol, to this liquid alcohol? The liquid alcohol will transform into gas, it evaporates. So we say in that case that alcohols also are volatile. Now there is an English word to which you can relate the word volatile. Remember the volleyball. What does the volley mean? Volley mean flying ball. So volatile, as we said in Arabic, بيطير. It means it transforms automatically or rapidly into gas. It's volatile. Now this is another fact. As the number of carbon atoms in a molecule of carboxylic acid increases, then the molar mass increases, and then the boiling point increases. This fact is not related only to carboxylic acids, it's related to all organic compounds. In addition to the molar mass effect, we have a high boiling point relatively for carboxylic acid that is due to hydrogen bond between the oxygen atom of one carboxylic acid and the hydrogen atom of another. Don't forget, when we explain the hydrogen bond in alcohol lessons, we said that it is an intermolecular bond. It means it is between two separate molecules. Look here. Here is the first molecule of carboxylic acid that is represented in green, and here is in blue. As you can see, this oxygen of the first molecule is bounded to the hydrogen of the second, and here is the same. So, due to this hydrogen bond, molecules of carboxylic acids are found as dimers. Dimers means two, so they are two linked molecules. Don't forget that hydrogen bond is a weak bond, so it can be broken easily, but it exists to increase the boiling point of carboxylic acids. Here is the most important part of our lesson, the chemical reactions done by carboxylic acid. Let's start by the reaction of carboxylic acid with water. This is a simple reaction, because you have to pay attention that carboxylic acid is a typical acid as the acids studied in acid-base. So, carboxylic acids are soluble in water and are partially ionized or dissociated in aqueous solution. Since carboxylic acids are weak acids, so they produce hydronium ion as usual and carboxylate ion. Look here, this is the general equation, RCOOH. When in water, pay attention, it's a reversible reaction because, as we said, carboxylic acids are weak acids. So what will result here? Here this H, it would be taken to move to this H2O. So we will still have RCOO minus, this is what we call carboxylate ion. Definitely its name changes according to this R. It means ethanoate, methanoate, propanoate, etc. And this H plus comes to H2O producing hydronium ion. So as I said, it is a dissociation reaction of a typical acid as studied in acid base. As an example, here is a carboxylic acid. As you can see, here is R plus H2O. We will keep the same part of the molecule here, but we will take H, so this one will become this one minus and plus H3O plus. The second reaction is the reaction of a carboxylic acid with a strong base. Here also is a very important reaction. It is almost a complete one. The general equation is the following. This is the carboxylic acid and this is NaOH. Here also you have to pay attention that carboxylic acid is an acid. So the H plus of the carboxylic acid here comes with OH minus of the base to give H2O, and Na plus here of the base comes to be attached to this O minus here. Now for organic acids, we don't write it RCOONA. Sometimes it can be written simply RCOONA, but they prefer showing this molecule or this compound called sodium alkanoate. They put point and comma. They write the ions first, the anion first, and then Na plus. But chemically, you know that this is an ionic bond in this part, and Na is attached to O. Okay, let's consider an example. Here is ethanoic acid that is known commonly as acetic acid that exists in vinegar, plus NaOH. It will give me, as we said, this H plus comes here with OH minus producing H2O, and this is what do we call sodium ethanoate, because here we have two carbon atoms, so it is ethanoate deriving from ethanoic acid. This reaction is very important in exercises. You will see it because it would be used in titration of carboxylic acids. The third reaction is the reaction between carboxylic acid and alcohol. It is called esterification. So, simply the reaction of any carboxylic acid with any alcohol will produce a molecule called ester and water. This is why this reaction is called esterification. Now, the general equation is the following. I will not explain it in details because the second lesson, the next lesson, it would be about esterification. But let me give you a brief idea. Here it's RCOOH. What will happen here? The OH of this carboxylic acid comes with H of alcohol here producing water, and this R prime that is now this R prime O comes here to give us RCOO R prime. As an example, here is again ethanoic acid and here is ethanol. They will give the following ester and water, as I said. this OH and this H will give me H2O. Again, about esterification, I will say that in the coming lesson it will be studied in details and we will re-explain this equation in details. Thanks for watching and I'll see you in the coming lesson.